In this video, we're going to have a look at the transformations of graphs. And we're first of all going to have a look at what happens when we add on a to our function. So let's have a look at an example. So I've got here the function y equals f of x, and f of x is a cubic function. And then over here, I've got f of x plus a number. Now at the moment, my number's 0, so the two functions are the same thing. So let's see what happens when we increase a. So I'm going to go for a is 1, and then a is 2, 3, 4. And then if I go down, a is 3, a is 2, a is 1, a is 0, a is minus 1, minus 2. So we can see that as we change a, the function or the graph is moving up and down, so it's shifting upwards. So if we increase a, it moves up a units, and then if we make a negative, if a is minus 1, it shifts, or there's a translation downwards of 1 unit. So it's a movement along the y-axis, or a translation or a shift along the y-axis. Now let's have a look at what happens to a particular point as we change the a value. So we're going to look at this point here, minus 2, 5. Now if I increase a, make a 1, what happens to the coordinate? If I make a 2, we've now got minus 2, 7. If a is 3, we've got minus 2, 8. And then it moves to minus 2, 9. So we can see that when a is 4, we add on 4 to the y coordinate. So it's the y coordinate that's changing each time. So let's go back and summarize that. So we've got y equals f of x plus a. So if this is our f of x, and if we add on a, the graph shifts upwards, or there's a translation along the y-axis. And we also say we can add a to the y coordinate. So it's the y coordinate that changes. So if a is positive, we add on the number to the y coordinate. If a is negative, we subtract a from the y coordinate. Okay, our next graph is going to be f of x plus a. So we're going to add on the a to the x and then do the function to it. So let's have a look at an example. So we've got the function f of x, the same as we had before, and we've now got f of x plus a. And we've got a is 0, so it's the same graph. So let's increase a. So if we increase a to 1, it's moved to the left. And if we increase a by 2, we're moving it to the left, where it's moved 2 units. And if we go down, if we make a negative number, so a is negative 1, we can see it's shifted 1 unit to the right. So this time it's a translation along the x-axis, and we can see that if a is negative, it moves, or it translates to the right, and if a is positive, it moves across to the left. Now let's have a look at what happens to the coordinate. So we've got this point here, this sort of maximum point or local maximum point here at minus 2, 5. Now what happens to that point, or what happens to this local maximum point as we change a? So if I increase a to 1, we can see that the point has gone to minus 3, 5. And then if I change a to 2, we've now gone to minus 4, 5. So it seems to be the x coordinate this time which is changing. So I'm going to decrease a. So if a is minus 1, we've gone to the point minus 1, 5. If a is minus 2, we've gone to 0, 5. So what we're doing here is we're actually subtracting a from the x coordinate. So let's summarize that. So f of x plus a represents a translation or a shift in the x direction. So if a is positive, it moves to the left, and if a is negative, it moves to the right. And what we do is we subtract a from the x coordinate. Now let's look at the third transformation, which is when we multiply our function by a number a. So we're going to have a look at y equals a f of x. So let's have a look at an example. I've got the same function here, f of x, which is a cubic, and I've got here y equals a f of x, and my a is 1, so the graphs look the same. So let's increase a and make a 2. So what's happened to the graph there? We can see that the point along the x-axis doesn't move. We can see that this kind of local maximum here has gone from 5 to 10. And then this point here has gone from 1 to 2. If we look at this point, it's gone from 3 to 6. So it's actually stretched upwards by 2 units. So it's stretched by a scale factor of 2. Now if I change a to 3, some of that's gone off the end of the scale, but we can see again it's stretched upwards. And if we look at this point here, where that y coordinate was 1, it's now gone up to 3. So we can see it's stretched by a scale factor in the y direction of 3. So that's going from 3, it's now at 9. So what's happened to the coordinates? So we can see here we've got this local maximum at -2, 5, and with a is 2, it's now at -2, 10. And then if we increase a to 3, it's gone off the scale, but we can bring that down so we can see it, and we see it's gone to -2, 15. So what we've done is we've multiplied the y coordinate by the a value. So let's summarize that. And we've got y equals af of x represents a stretch in the y direction, scale factor a, and what that means is we multiply the y coordinate by the number a. Now the next question is, what if a is -1? So we end up with y equals minus f of x. So let's have a look at the example we had. So I'm going to change my a value into -1. So that's a is 0, and then we've got a is -1. Now we can see that the whole graph seems to have flipped upside down. So it seems to have reflected in the x-axis. So where this was at 1, it's now gone down to -1. This point here, which is at 5, has now gone down to -5. That bit along the x-axis has stayed where it was, and where we've kind of gone up and then down, in this bit we've gone down and then up. So it's actually reflected in the x-axis. So summarizing that, we can say that when a is -1, we've got a reflection in the x-axis, and what we do there is we multiply the y coordinate by -1, or another way of thinking about that is the y coordinate becomes negative. Now the last transformation we're going to have a look at is this one here, where we've got f of ax. So we're going to multiply the x by a and then do the function. So again, let's have a look at an example. And we've got f of x over here, the same graph, and then we've got f of ax. I've started off with a as 1, so the two graphs look the same. So let's increase a and see what happens. So if a is 2, we've got that. And if a is 3, 4, 5. Now what's happening here is it's being stretched in the direction of the x-axis, but this time it's being stretched inward, so we could call it a squash. It's being squashed in. So if a is 2, it's actually come in halfway, so that's gone from where the x-coordinate is -2 to where the x-coordinate is -1. And this bit over here, we've gone from where the x-coordinate is 1 to where the x-coordinate is 1/2. So it's the x-coordinate that's changing. We can see that the y-coordinates are staying exactly the same, but it's the x-coordinate that's moving inwards of a scale factor of 2. So let's summarize that. And we've got, it represents, I call it a squash in the x direction. I've said a scale factor of 1 over a, because we would actually multiply it by 1 over a. So if a is 2, we've kind of multiplied by 1 over 2 to bring it in. And what we do with the x-coordinate is we divide it by a. So we've gone from -2, 5 to -1, 5. And this one here would be 1, 5, and this would be 1/2, 5. So it's the x-coordinate that's changing. Now the last question is, what if a is -1? So let's have a look at the graph and see what happens if a is -1. So if I go down and make a, let's say 0, a is -1, can we see what's happened? Well, we can see that whatever was on the left-hand side is now on the right-hand side, and what was on the right-hand side has now shifted to the left-hand side. So the whole graph is being reflected in the y-axis. And then what happens to the coordinates there? Well, this one here, -2, 5, goes to 2, 5. This one here, which is 1, 5, goes to -1, 5. So it's the x-coordinate that's becoming negative. So summarizing that, we say it's a reflection in the y-axis, and we multiply the x-coordinate by -1. So now it's your turn, and this is what you're going to do for homework. So in the C1, actually I'll write that down, so C1 book, you're going to do the review exercise, which is towards the middle of the book, which is page 71, and I'd like you to do question 16 and question 17, and you're going to hand that in the next lesson. I'm going to ask you to make sure you do those questions on a separate sheet of paper and then hand that in the lesson.